talk and made it start very unnecessary. Thank you, Gergely. You are very constructive. So anyway, what Gergely is talking is true. My name is Ágnes, and I will talk today about R in infrastructure and business analytics. And the main title of the talk is Use the Right Tool. Why exactly the right tool? It's good to know about me that I spent my last 4 years in the academia at the university and doing some research in infrastructure analytics. And recently I joined a data science company called Secret Sauce Partners as a data analyst. And if you go to the career site of the company and start browsing for engineering jobs, which I did after I accepted the offer, then you will see that our motto of the whole company is that, okay, we don't force you any technological stack on you, but we believe as a company that you always should use the right tool for the right job. Well, my first thought was, okay, I will get fired very soon. The last time I learned a totally new technology, a new language from scratch, was 4 years ago. And of course, the second thought was, okay, calm down, you are going to be great. Because I can learn everything you know by doing. And at the end of my journey, I will be the super data analyst, rockstar, unicorn with a super sophisticated technological background. And over time, it turned out that none of these have happened. Yeah. But instead, when I got my first exercises, my first tasks at the company, I automatically looked for R packages, existing R solutions, which is, let's face it, not very hard, with 10,000 R packages there on the internet. And as I deepened my R knowledge, I realized that actually almost everything can be done using R. And this made me very, very special. You know, I was a special snowflake in the team. We are the exceptions because there are, of course, general rules like always be yourself, blah, blah, or always use the right tool. But if you think it through that there are exceptions, for example, always be yourself unless you can be Batman. And this is the other side. Use always the right tool unless you know R. Because then your days are practically saved. You can survive in a data analysis position using or knowing practically exclusively only R. So this is the first part of the talk. The second, infrastructure and business analytics. What do I mean when I'm saying these expressions? Imagine that you will have a service and lots of happy, enthusiastic users communicating with your servers through different devices. Maybe you are providing a communication platform. Maybe you are providing a streaming service. Or you are just give the opportunity to your users to capture and battle and train non-existing virtual creatures who are actually not there in your neighborhood and drive all of the colleagues and all of the friends practically crazy. Anyway, no judgment. This is a legitimate type of entertainment in the 21st century. Back to the service. Usually, if you have ever seen a complicated system, this is not one box. This is millions of boxes wired to each other, communicating with each other. So you should expect something like that. And of course, somewhere up in the cloud. When I say infrastructure analytics, I usually mean the left side of this chart. What are the typical components? What is the resource utilization of these components? What are the bottlenecks? How your system can handle the workload coming from the users. On the other hand, if I'm talking about business analytics, in this context, I don't mean risk or revenue or profit analysis, but rather a product analysis. How your users are interacting with your user interface. How you are using your service. Of course, for a successful service, you will need both, because you cannot evaluate your user experience if you are not aware what your system is capable of. If you don't know the typical response time, the typical availability of your system, the planned and non-planned outages. On the other hand, if you really would like to plan the capacity, plan your scaling, anything which is related to design. It's essential to know how your users are actually using your service. When, how. If you can find these behavioral patterns, then you can prepare for the bigger and larger workload. Where did I learn all of these things? Of course, from two places. First is the university, as a member of the fault-tolerant systems research group. What does it mean? We usually deal with systems with high availability. This means that they can stop functioning only for a couple of minutes or hours in a year. And it's essential if you are streaming a conference to the world, or by the way, if you are sitting on a plane, you really would like to believe that it won't stop working just because something happens in the environment. So this is the first part. Second part, yeah, just a nice word appeared. Okay, sorry. Data analyst in product management. This is the secret sauce partner side. The SSP is a data science company specialized in fashion industry. What does it mean? We get lots and lots and lots of data from our partners, who are usually shoe and clothes retailers. We analyze this data, and we are trying to help our users with finding their size or style preferences. Yeah, that woman again. So if you are, for example, browsing a Cynthia Rowley burgundy colored dress, because why wouldn't you do this in your free time? And you are not certain with your choice, with your preferences, either related to size or style, and you really wouldn't like to throw $700 just out of the window, because assumingly you don't, then we can help you. This is about me. Well, what is about the data? If you have ever typed top in your console, or if you have ever checked your performance manager on Windows, then what you saw were numbers refreshing in each second, or in every 10 seconds. So somehow you expect a continuous sampling. For one click, for one clock tick, you expect a new data point. On the other hand, if you are analyzing the footprints of your users, then this is rather a stream of discrete events. This user refreshed a page, or clicked a button, or hovers on an image, and so on and so on. So, however, most of them have all of the time-related things. If you are familiar with the Zoo or other time series analysis packages, then you can apply them rather on the first one, but not the second one. This is just a different type of data. How do you get this kind of data? It's a typical trick, independently from the domain, that you store your data in a database for a while, and then you just save it somewhere because you don't have the storage capacity for here. In infrastructure analytics, this time interval is much shorter, and in projects you can find, for example, text files, but 20 gigabyte large text file, or separated value files, tab, comma, whatever. I know that lots of speakers before me have mentioned this, but I would like to join them. God bless data table. And Arun and Matt and whoever ever contributed to this package. It saved us hours, day. I cannot emphasize enough that 4 years ago or 5 years ago, when we weren't aware of that package, we suffered so much with all of the simple steps. I mean, reading a file, filtering, joining. It's just a miracle. On the other hand, well, if you are a data science company, you have everything in a database. This is a much more unified API. It's a little bit easier there. What can be a challenge is web scraping, and this is where the real magic of R happens. That you are real-time scraping the web, query your database, analyze the data, and automatically upload the report somewhere in the cloud. And you don't have to touch any other languages. Transforming the data. Usually we like thinking of data as a wide data set, as a feature vector. We don't like that, okay, in the first second, the CPU usage was that kind of number, and the second was that kind of number. We really would like to see that the CPU, the memory, the network bandwidth, or the disk I/O, these are all in the same row. So you have to switch usually between the long and the wide format. And I didn't talk about other transforming steps because you know these probably at least as much as I do. And if I would be a very sophisticated R user, then I would say that yes, I'm using the tidier and the dplyr packages, and I really do when I have time to code. But somehow I have such a long friendship with Reshape2 and dplyr that if I have to do something very quickly, then I just drop the pipes and go back, just to the old formula. Visualization. Yeah, this is my favorite one. Lots of people know that I'm a big fan of data visualization. I think I've tried almost everything which was available in R. But as we usually handle tabular data, then I cannot go without mentioning the ggplot2. However, I have to mention that actually typically the most frequently used functions have changed, because if you are thinking of time series, then usually use geom_line, geom_point, and so on. And if you go to the business side of this, then these are usually heat maps, density plots, conditional density plots. There was a time in my PhD studies when I was exploring how the typical BI tools can be used for infrastructure analytics, and it drove me crazy. This is a Power BI screenshot, but this is the same for Tableau. Somehow data analysts like aggregation. And it drove me crazy. If you store a data point for if you store 2 data points for Monday and 2 for Tuesday, then it's not easy to plot all of the 4 points, because somehow the tool forces you to choose an aggregation metric, and all for Monday and Tuesday to choose only one aggregation, whether the sum of the points or the average, and so on and so on. And I thought that this is somehow a little weird obsession with this kind of visualization. And I know today that they are right. After 3 months, I realized that it was only 2 cases when I had to zoom into one single data point, and otherwise I will aggregate everything. And I'm really embarrassed, but I will skip a whole slide and just go to the summary, because Gerdu will be angry if I run out of time. So I spent practically 10 minutes talking about random data packages. You know most probably better. I am, in worst cases, you are the creators of these packages. Why is it good for? If you are really interested what people with special background or domains are dealing with, then just go to Twitter. It's mind-blowingly unprofessional, but it works. You can know, for example, what are the 7 favorite packages of a data visualization expert, or what you should use if you want to be a political science research associate, or I don't know, a super meta magic R wizard like Gabor. You can learn actually from Twitter. And David Robinson made a summary of these votes, and actually it turned out that those people usually use the exact same packages I do. So it's embarrassing because I'm not a special snowflake anymore, but it taught me one thing. At the bottom of my heart, I'm rather an educator and not a researcher and not a data analyst. I really like teaching and transforming the knowledge. And when I learned R 4 years ago, then I was taught linear modeling and Kolmogorov-Smirnov statistics and matrix multiplication, which are useful things and smart things. But if you would like to gain new users into the community, just give them sense of achievement. With teaching them the typical data munging, cleaning, transforming packages, and leave the Ágnes dataset alone. Find something interesting and stop teaching data science before the students, or let's say students, yet ever have the sense of achievement, because they will be much more, they will enjoy data science much more if you start with these. I don't dare talking further. I'm just waiting